Welcome to Medical Matters, episode 7. Today, my name is Alicia Edmond, and I'm going to be moderating here with Dr. Andrew Jones. It is August, and whoever would have thought it would be still in this COVID pandemic?
Yeah.
Yeah. So why do you think this has lasted so long? I know when it came out a year and a half ago, I was hoping it would have gone away.
There's a lot of reasons, a lot of particulars, which I'm going to get into as we go through this podcast. People have a lot of information, a lot of questions, so forth. Definitely going to cover that. My last podcast was December of last year.
Yeah, I was going to ask what happened.
A lot has happened since last year. A ton of things have happened. I was in this space where everybody was an expert on COVID. When you have something the way the human mind works is, when you hear something for so long and you have an opinion, your mind becomes embellished in that opinion and you stick to it. So everyone is a quote unquote expert on COVID. So nobody was listening. I would say one thing, they would say, "Oh no, doc, that's not true." And I was like, well, I have all the literature to support what I'm saying, but it didn't matter. Everyone was stuck to their own beliefs. So January, I'm seeing COVID patients. February, March, April, May, I'm just seeing patients. I let people talk, and if you want to listen to my recommendations, fine. If you don't, that's fine.
So what were some of your recommendations?
Some of my recommendations were how to properly wear the face mask, talk about the social distancing, it could be more than 6 feet, talk about cleaning your hands, the air, everything I was talking about from a scientific standpoint.
Yeah.
But how it equated and related to what people were doing in everyday practice, it caused it, they didn't want to listen.
So I know for someone like myself, you hear so many things out there. You really don't know where or what to believe. Why do you think that's occurring?
For various reasons. So the experts are talking about something that they're not really experts on. And when you ask someone a question, the hard thing to do is say, "I don't know."
Yeah. So who are you considering an expert?
An expert is the person who knows virology, the person who knows the immune system, the person who knows the microbiology behind what's going on, the person who wrote the paper on COVID at some of the top universities and institutions in the country. Those are the people that know what's going on. The guys in the lab doing the studies, randomized controlled trials and so forth, those are the experts, but they're not the ones speaking. You have people in all facets of government and healthcare institutions who don't know about COVID. Brilliant people, smart. And I said this in my last podcast, but they are talking about a subject that they don't know very little about. And they're making recommendations based on knowledge, that they don't have.
Yeah, I can kind of understand that, but for someone like myself, I'm being told several different things. How do I know who to trust, what to trust? Now they're offering out all these lovely incentives and everything to get a vaccine. How do I know if that's something I should be doing?
So that's the thing. So it goes back to the human mind. So if you can't say, "I don't know," or give a good reason, and you're just pushing, it's almost akin to bullying, where you're saying, "Get the vaccine. If you don't, you're an idiot. You're dumb. You're stupid. What are you doing?"
Yeah.
And then on the flip side, you're like, "Well, I'm gonna be nice. So I'm gonna give you these free concert tickets. I'm gonna give you free daycare. I'm going to, cash prizes, grocery gift cards, just vacation packages like University of California, San Diego, free tickets at San Diego SeaWorld." I mean, that's suspicious, because nowhere in medical history have we given incentives to take medical treatment.
Fully agree.
People are right to question what's going on.
So from your perspective, what is the truth on why this pandemic is occurring and how we should be handling it?
So before I talk about that, I just want to spend a few minutes talking about what I've come to realize over the past few months, and why I've been quiet, and why people are set in their ways.
Yeah.
And why I almost didn't want to do this podcast. And I didn't want to do this podcast because you're going to have people polarizing the pro-vaccines, gravitating to like, "Oh, he said this, I'm going to ignore that. He said this." Then the anti-vaxxers, okay, yeah, this goes in line with what I'm thinking. I don't believe that. Yeah, even though I have all the evidence, this goes back to something called belief perseverance, which is in psychology, also known for the backfire effect. The backfire effect means that whenever someone tells you the truth, instead of changing your beliefs and agreeing the truth from your opinion to fact, you adhere more strongly to what you believe. And the reason behind that is you're questioning your self-concept, who you are. You feel like it's being attacked. And so you adhere strongly to your beliefs. And so I would see all these things, and I was just reluctant to do another podcast until people close to me kept asking, please have all these questions. And I said, you know what? I'll do the podcast for you. The people out here are far this way. They're gonna pick and choose what they want. But I wanted to do the podcast where I could just tell the whole story, the whole picture. Here you go. Take the information.
That's very important.
You know.
I agree.
You know.
So I know we've had several pandemics. Can you tell us some more about history, right? Mm-hmm. And how we can apply it to today before we fully dive into COVID?
Mm-hmm. Yeah, so you have the Spanish flu,
okay,
which was one of the biggest pandemics in history. And I'm gonna show some pictures while I talk about the Spanish flu. So basically, the Spanish flu happened in February 1918 and ended in April of 1920. So and it had 4 waves. It was right after, you have to realize the times was after World War I. It was a Great Depression. People were in crowded conditions. There was no money, no food. People were getting sick. In the first wave of the pandemic, in the Spanish flu, there was a lot of censorship. The government was downplaying it, said that, this is just a regular cold, don't worry about it, don't need to do anything, go about your lives. Then the cases got higher, it got worse. It was affecting people 20 to 40 years old and above 65. That's who it was killing. Mm-hmm. There were superimposed bacteria infections on top of that, killing the majority of people. The people were bleeding from all the orifices, the eyes, the ears, just like all over. Basically from disseminated intravascular coagulation, which is where you just massive clotting in the whole body.
Yeah.
It was horrible. Just as a comparison, before I say that, then the fourth wave, and then it just kind of went away. They tried to make vaccines,
right?
But the vaccines were based on bacteria, not viruses, so that failed miserably. Then after the fourth wave, then everything, it was just so much censorship, so many things.
So how do you think that's similar or different to our current COVID pandemic?
It's very similar, and here's a picture of all the pandemics throughout history, showing you like Spanish flu, also showing you 2002, SARS, then swine flu, then MERS, and present day SARS coronavirus 2. And if you notice, we have all these pandemics, and fast forward 100 years later, we still don't have a system in place to combat these pandemics. And the pandemics, if you notice throughout history repeats itself.
Yeah.
We're going to keep having pandemics as these viruses mutate. So one famous Spanish philosopher said, those who forget the past are condemned to repeat it. That was George Santayana, a Spanish philosopher. He said that. And it seems like we keep going through the same things because we're not aware of our past. I wonder how many people out there actually have done the research on different pandemics and looked at the Spanish flu. Then there was like so many similarities. So.
Well, good. So now we can dive into COVID. We have lots of questions that I'm eager to ask, and we'll let you explain because he's definitely done a lot of research. And the beauty of it is that he's right here with all these lovely magazines and facts. So, what can you tell us from a high level about the current COVID crisis?
Definitely. So also with this podcast, I've spent hundreds of hours doing research, getting all this information together so that I could present it. I didn't just want to do a podcast with the knowledge I've had off the top of my head and just talk. I wanted to have up-to-date data to show you because I wanted to give you the information. And the one thing I tell my patients, and some of you guys are going to laugh if you're my patient, is here's the information. When you walk out that door or you turn this podcast off, what happens next is up to you. My job is to give you the information. So to jump straight into COVID, which everyone wants to hear about, is I wanted to talk about the cases. So the case of COVID, and I told you I did mention this. I wanted to talk about COVID compared to the Spanish flu. So Spanish flu was 1/3 of the world population. So 500 million cases, and around a 10% mortality. So around 50 million deaths. And compare that to COVID, based on the data as filming this podcast, 192 million cases and 4.2 million deaths in the world. So
Wow.
a huge difference.
Yeah.
A huge difference in the podcast. Sorry, in the mortality rate of the different pandemics. So compared to COVID, hopefully we definitely don't reach those numbers. But like
Do you think we will?
based on if history repeats itself, we're in the fourth wave. We should be ending soon. If history repeats itself, we should hopefully. But we'll talk about the mechanisms and everything as we go
Okay.
through the podcast. So there's a lot of unknowns, but I'm going to talk about what we do know. So,
Yes.
so COVID, for example, with COVID, and people always ask like, whose fault is it? It's the anti-maskers. It's the people who wear the face masks. It's the anti-vaxxers. It's a culmination of everyone, indirectly and directly,
Okay.
doing things that's keeping the pandemic going on. And what I say by that is, for example, if normal talking produces 100,000 particles into the air per minute. Per
That's an
minute.
interesting fact.
And depending on the airflow of fans and so forth, and what's going on, doors closing, it can travel across the room. And also, let's say you're sick with COVID, and you're asymptomatic, but you're infectious. You have a lot of particles, and one simple sneeze and one simple cough can transmit. Ready? 200 million. 200 million particles into the air.
That's a lot.
Yeah, traveling 100 miles an hour.
That's gross.
Further than 6 feet. It's true that most droplets fall to the ground, but if you think about 200 million going into the air,
Yeah.
and scientists estimate based on some studies, they need between a conservative number, 100 particles, virus particles getting infected, and some say 1,000. So if you have 200 million going to the air and traveling, and you only need 1,000, that's just one breath, can cause infection. It's simple that one breath can cause that.
Man. So knowing the breath and sneezing particles can travel so vastly, how does that coincide with the direction that we've been given for the hand washing? and all that?
So the difference. So the thing is, in the beginning of a pandemic, hand washing, great. Social distancing, great. Wear your mask, great. Just like as an analogy, when it starts to rain, umbrella, rain boots, raincoat, you're great. In a hurricane, not so great. Because right now, you got to realize people are coughing, sneezing, hundreds of millions and trillions of particles going into the air, all over the surfaces. So you're trying to do the things that work at the beginning of a pandemic later on, and that's not going to mitigate or stop a pandemic.
So do you think we were misguided?
We're not misguided. We just let things get to a certain point to where the things that we relied on and that helped make a small impact on. That's what happened. And when I say everyone's doing their own thing. For example, every state has different. You have the same virus. We know the genome of the virus. We know how it spreads. We know what it looks like. We know how long the symptoms are. We know all these things. Same virus. Every state, every business, everyone's doing everything that they want. And I watched this month after month after month. And I watched the cases, and I didn't say anything because I was just watching, because people were going to listen to me. Like they're stuck in their ways and they believe what they want. Backfire effect, believe perseverance. So I just watched this. I would have watched people at the gym with the face mask on, and they're sweating, and their face mask would be soaked with sweat, and
So
they
would you not
can't breathe.
recommend that?
In the gym, no, there's no studies to show that, and also it impairs your oxygen. So it's there's no point if you're in the gym and it's wet.
Well, Doc, I could have used this advice months ago.
Oh, that happened to you?
Absolutely.
You were sweating?
I was running. I'm a runner, and yes, my time got better, but I could have totally used some reassurance that I didn't need it.
Yeah.
Yeah.
So, there's I do want to show this picture on compliance of hand washing compliance. There was an article that they did that was actually pretty interesting, talk about compliance and hand washing, social distancing, that was actually pretty depressing. They have these automated sensors in a lot of hospitals across the country, and they monitor somebody coming into the room, somebody coming out, and how many times the sanitizer was used. They found that there was only 50% compliance. So if you go into the room, wash your hands.
Yeah.
You leave, clean your hands. So that's 2 times. So the person was only doing it once. So that was actually pretty disheartening. And just to, also I wanted to show you the size of the COVID particle, just to backtrack a little bit. Here's a picture of the COVID particle compared to other things like a hair follicle, red blood cell, and so forth, just to give a comparison of how how small it is, and how when you cough, sneeze, and it's spreading everywhere, and it's flowing, and it's just so easily transmissible.
So are you in agreement that definitely to cover your mouth and nose when you sneeze to prevent that?
Of course, but you got to realize when you do this, you're still blunting the force of what's going into the air. 200 million particles.
I don't know.
Like one sneeze.
Teach me. Yeah.
So you got to realize somebody sneezes 5 times,
Yeah.
and then everyone's and the people wearing a face mask. They don't wear it wrong. They wear the same mask over and over and over. They touch it.
Yeah, there's been a lot of misguidance.
Yeah,
on that.
their hands have COVID. Then they touch their keys or their cup, and they touch their eyes, and they get infected that way. 1,000 particles. Like everyone does things every day to put them at risk. And that's why the case is going to keep going up, no matter.
So then I guess my next question is, while working through the pandemic
Mm-hmm.
and working with COVID patients, even continuously now, are you seeing vaccinated patients like still getting reinfected, and what do you have to provide us some information on that?
Yeah. So vaccinated people are getting.
Are they being hospitalized for it?
They are being hospitalized, and I put the data down, and from all the all the data that I'm getting, all these numbers and percentage so forth, are coming from hospitals, healthcare facilities, nursing homes, giving the data to the county on all these different states, and to give it to the counties, and then that's what is to get the data. So It's
Okay.
not numbers that I'm making up. So you can do the research yourself and do your own to verify my numbers. So I wrote the hospitalizations, the vaccinated 0.039%. Again, 0.039% of people who are vaccinated are being hospitalized. And those that are hospitalized, no surprise, are the high risk people.
What do you consider high risk?
High risk are those individuals, elderly, above 60, have comorbidities, high blood pressure, diabetes, and BMI above 34. That's actually, and the problem with that is people who are high risk don't consider themselves high risk.
Right.
I can't tell you how many times in the office I have patients who, I had a guy today, 400 pounds, high blood pressure, diabetes. He was 36.
He's young.
Yeah, and he said, "Oh, I'm not worried about COVID." And I said, "Did you get your vaccine?" He said, "I don't need it. I feel great." And I said, "You're the kind of person that I signed the death certificate for." And I'm not even lying.
No.
He said, "Oh, I don't want to hear that. I'm fine." And I let him walk out. And this goes back to people are tired of hearing about COVID. And so when I tell someone the truth, it goes in one ear, goes out the other. That guy, and also I forgot to mention, his blood pressure in my office was 210 over 120.
So what does that mean?
Which means that he was high risk for having a heart attack and
So
stroke on
what
the
is-
spot.
What is a normal blood pressure?
Well, 120 over 80.
Oh, and his was what?
210 over 120. And I told him to
Okay.
please go to the emergency room. I said, I'm nervous. I said,
Yeah.
everyone in the hospital says, "Oh, Dr. Jones, I felt fine until I started having a chest pain. I felt fine until the left side of my body went weak. I felt fine. I was just eating, enjoying my family, and then I couldn't talk. I couldn't
Yeah.
think." And that's why cardiovascular disease is called a silent killer for that reason. And actually, we talk about COVID, cardiovascular disease killed 1 million people last year. 1 million people, and actually that's a
How
conservative
many
number.
people did COVID kill?
Last year,
Not to fact check you or anything. I'm
last
just
year, yeah, it was something around 300,000. I know it's 600,000 now,
Yeah.
but it's, you know.
I get it. So, question, can you explain to us what is the difference between asymptomatic COVID patients and a regular vaccinated person who may be a little bit symptomatic?
An asymptomatic carrier is what is we found based in a lot of literature and so
Okay.
forth and articles in a lot of scientific journals. Asymptomatic carrier is a person who either when they get COVID and it's in their nose, it starts in the nose and it goes down the throat into the lungs.
Okay.
Okay. And once it gets to the lungs, it's a slow process, but once it gets to the lungs where it causes most of the damage. And that takes 2 to 14 days before you start happening, showing symptoms. So you're an asymptomatic carrier, which means while you're talking and you feel fine, you're breathing into the air the particles.
Right.
And then someone else comes by and they breathe it and you're infecting them without them even knowing it. They don't show symptoms till days later. And then by then they've exposed someone else and someone else and someone else. And so they are the ones giving it. And then the vaccinated person,
Yes.
so the vaccinated person can still spread COVID. And the reason being is, vaccinated or not, you're still breathing the same air as someone else. So the virus is in your nose as you're breathing it, and you're breathing it out. So yes, your immune system is primed and ready with the vaccine to protect you, which is great, but you're still breathing out. You got to realize, just because you're vaccinated, there's not a wall. You're still exposed to SARS coronavirus 2 all the time. You're still breathing it in and everything. It's just the difference between you when you're vaccinated or you're naturally immune, which we're going to talk about, is your immune system clears infection very fast. So you're not in the hospital. So that's the reason for all the push of being vaccinated, or, but you're still breathing it in. So you can still test positive for COVID after, even if you're vaccinated.
So understanding that and having it be August now, flu season is right around the corner. What do you foresee happening between the cold and COVID?
Actually, last year when I did my podcast, I think it was in August of last year, I predicted that there was going to be another shutdown because the way the cases were climbing, that we're going to get to a peak to where it's going to be right in the wintertime, it's going to be right cold and flu season, and it's going to overwhelm the healthcare system so much to the point to where you have to shut down. This is an anomaly because we're in barely August. Yeah. We're in barely August, and the cases are still climbing through the roof. And it's August, and so listening to other people talk and the way viruses work and so forth, this thing could hit a peak in the next 4 to 6 weeks and then come down so that by the time cold and flu season gets here, we're only worried about the flu. This is an anomaly because we've never seen this. Last year, it was like, okay, there's upward trend. Here's cold and flu season. They're going to meet at the same time. This is different because here's cold and flu season, and you've already peaking. You're already, you're going to plateau before cold and flu season. So we're not sure what's going to happen this cold and flu season.
What do you predict?
Our prediction based on what I see is, first off, hospitals are packed anytime during cold and flu season.
Right.
And if in your mind every day, COVID, I'm scared, you see in the news ICUs are packed and so forth, you're going to stay home. You're going to tell everyone else, and then the government is going to respond by saying, well, we have no choice but to shut down because America's scared. So because if in your mind is COVID, hospitals are packed, then you get shut down.
So what are the treatments for COVID, if any? Are there treatments?
So the treatments for COVID is, some of the basic ones are, and this is the thing, we're a year and a half in this, I believe, a year and a half. There's only one FDA approved treatment, that's remdesivir, which works limited. It's antiviral that works limited, and in certain cases. We do have the monoclonal antibodies, which helps in the beginning.
So what is that?
Monoclonal antibodies is an antibody that targets the spike protein, so on SARS, to block it from getting into the lungs.
Okay.
But it's only effective in the very beginning stages. Once the virus is inside of your cells, the monoclonal antibodies are not going to work.
So is that the same for someone who's vaccinated?
No, once you're vaccinated, you don't need these treatments.
Oh. I don't know, I'm asking.
Yeah. You don't need the treatment.
Okay.
Yeah.
All right. So I do have a bunch of questions from you guys that I'm going to ask and help him ask Dr. Jones to clarify for us. So as you guys know, we've had lots of news breaks about different variants that are out there for COVID. How many are there?
Okay, good question. So I'm going to go into the scientific part of the different variants. So there's 9 different variants. If you look at the screen right here, we're going to put up, you see a picture of the different variants around the country, the ones that are most concerned, and also showing, you look at the picture, you see their relative rate of transmissibility compared to the original SARS-CoV2 at the bottom of the graph. And you see that the Delta variant is the one that's the most transmissible, and that's the one that we are the most concerned with because viral loads in the nose are 1,000 times higher than they were seen with the original SARS-CoV2. So that's more of a concern. The mortality rate is not higher, thankfully, but it is transmitted at a lot higher rate and is overloading immune system. Because
So where do these variants come from?
These variants actually, we have some literature. These variants are coming from immunocompromised people who are long COVID, they're in the hospital, they're in ICU. There was one article I read in the Journal of American Medical Association. This one guy, they did genomic sequencing, and he had 40 different mutations in SARS-CoV-2. 40
Really?
different mutations. So he was.
So you could have more than one.
Yeah, you can have more than one. So he eventually died. He had B-cell lymphoma, so he got COVID. He was hospitalized, and then he was fighting, and the virus was mutating in him when he was getting all these treatments, monoclonal antibodies, the remdesivir, the steroids. So the body kept evading the host immune system and these treatments becoming stronger and stronger.
So can a non-immune compromised person get more than one variant?
Yeah, you can. You can. That's why during you see this all the time, and it's a shock to people when they hear this. But you can. So they'll say you can get the flu and the coronavirus at the same time. You can have adenovirus or rhinovirus at the same time. You can have 1 or 2 variants at the same time. It's not uncommon. The reason you don't have, there's over 200 respiratory viruses. The reason you don't have all 200 at the same time, because there's only a certain receptor that they bind to in the lungs and so in a respiratory cell, so they can't all bind at the same time. It's like trying to go through a door. Like everyone can't go through the door at the same time.
So I have another question, just to help me further understand. With all these variants, how often do they mutate? Or do they mutate?
Yes. So any virus
Okay.
is mutating.
Okay.
Just as a comparison, the flu mutates at a rate of 50 times per year. SARS-CoV-2, based on just some data in genomic sequencing, mutates at a rate of about 25 per year, or you can have new strains 2 times per month.
So question, do you, just like we have the flu vaccine every year, do you think there's a possibility of having a COVID vaccine now every year?
There is. I mean, because it's mutating half as fast as the flu, you can definitely do the same thing, have a SARS vaccine every year. You could. But everything is still new. We're trying. All this new data is coming into us at 1,000,000 miles an hour. We're processing it. The FDA is everyone's processing all this information. So as time goes on, we're going to have to be able to answer that question in more detail.
So then, why are these variants mutating so fast?
They're not mutating fast. It's just that as time goes on,
Or spreading so fast?
Because they're mutating in the spike protein. The spike protein is the protein.
You got to break it down.
Oh, sorry.
Okay. Yeah, I don't know. What you got? Yes, the spike protein.
So they're in the region that they bind to the ACE2 receptors in the lungs. So I'm sure everyone's seen these pictures. So the binding site of the virus This reminds me of, you know, my dad would always have me talk to people about something because I would go over their head. And it was unintentional.
I need him to bring it down.
It was unintentional.
For me
I
so
would
that I can understand.
I would get excited. Someone would say, like my dad would say, "Hey, tell this person how how their immune system is helping." They're like, "Oh yeah." So you have the JAK-STAT pathway, you know, doing antigen-presenting cells, and then you have like the major histocompatibility complex 1 and 2. They have the CD4 coming in binding, and in my head I'm just like thinking about all these pathways, and they're like, "I don't know what he's talking about." You know, but I answered their question. They wanted to know how the immune system works, so I told them. Yeah. But I had to learn how to simplify things, so that's the one thing I'm still working.
No, hey, it makes me feel better to know that you actually know what you're talking about. That I may have to go and look some things up afterwards.
Yeah,
you know?
and I recommend that anyway. So please, you know.
Absolutely.
Yeah.
Oh yeah, never take anybody's word.
All right, sorry. Back to what was your question?
Okay, so we're gonna go ahead now. Another question that came in is. Incubation periods, right? How is the incubation period for the different variants? And just really clarify, what is an incubation period?
The incubation period is a time that the virus needs to process and get ready to emerge and wreak havoc on your body.
So does that mean I can be asymptomatic?
Yes.
And it can be, oh wow, that's interesting.
So remember, that's why they said the whole 2 to 14 days for the original SARS. Now that's been cut down to 3 to 6 days with the Delta variant because it transmits so fast.
Oh wow.
And the reason it transmits is because there's mutations in the virus binding to the cells.
So if I've had COVID, should I still, and I've never had symptoms, should I still be worried about the variants?
So there's basic literature. That's a good question. So I'm going to put up a picture of an article here in the Cell magazine showing how that it's called the targets of the T cell responses. They saw that people who were not hospitalized, but they had symptoms of COVID. They tested positive, and they took a sample of people aged, a broad sample, 20 to 62 years, I believe, and they checked their symptoms and they monitored them, and they took samples of their blood, and they saw that 100% made antibodies and 100% made T cells, CD4 T cells, and they also found that 80% made a specific antibody called IgA. IgA is an antibody found in the mucosal membranes, like your nose, for example, and that's on the front part of the immune system fighting COVID when you first exposed to it. And they found that. That was just that population, not the hospitalized, not the severe. It was just, they just wanted to get a regular general census because most people are not hospitalized by COVID-19. So they just wanted to get a general census like, okay, well, the majority of people, yes, there are exceptions, but how would the majority of people fare with COVID-19 if they were exposed and they had symptoms? Like, what would happen? And that's what they found out. They 100% had an immune response. They were fine, you know. But like I said, there's always exceptions to that. But that's what they found based on that. And there was the same lab. They actually took samples of stored plasma from 2015 to 2018, and they had the SARS coronavirus 2 to mix with it to see if there was any type of immune response. And they found out that 50% already had T cells, you know, the long-term T cells that actually were recognizing SARS coronavirus 2. And if you know from history, there was no SARS coronavirus 2 in 2015, 2018.
Right.
So it's just that, and the reason for that, based on, you know, immunology and talking to some of my colleagues, is that whenever you are exposed to a pathogen, your immune system is so complex, it makes like a deck, a memory. Like, okay, I recognize you, but then what if you look different next time? What if you're shaped differently? So it makes a whole library. Your immune system can make billions and billions of different types of antibodies, billions of different types. So when you're exposed to COVID-19, your memory B cells and your T cells have a library ready for the next mutation. Like, so all of this is new to everyone, but this is not new to the immune system. Your immune system has a backup. So when it's exposed, that whole library, one of those antibodies and T cells is going to recognize.
Okay, so just for clarification, if I have had COVID, I shouldn't be worried about the variants because my library
Based on
may have
that's a simple way. It's a
Right.
lot more. I can go.
No, I'm trying to
Yeah.
to make sure I understand.
Yeah. So the simple answer based on how your immune system works and
Yeah.
and the different tests they've done, you should nothing to be worried about. No.
Okay. Well, that's good to know, right?
But there are exceptions. But
Yes.
for the most part, yeah. These questions seem simple, but they're not. So.
Nothing in medicine is simple, folks.
No.
Okay.
Yeah.
Another one that we've all been hearing about is the rise. School starting. Summer camps are ending. We have football season starting. The kid. What is your perspective on the rise in cases in children?
Okay. It's a respiratory virus, and is running through countries worldwide. So healthy, young, old kids alike. So we're just running through everyone. So yes, cases in everyone's going to go up. Kids are going up. The mortality rate in kids, from some of the literature, is 0.01%. And there was actually one professor at Johns Hopkins. He did some data research on the kids that did die from COVID-19, and he found out that they all had underlying conditions. People don't like to think about this, but hopefully your child is healthy, but there are some kids who have genetic diseases.
Yeah.
They have cerebral palsy. They have childhood cancers. They have defects in their immune system. They have
So again, immune compromised.
they're immunocompromised, and they found their obesity. They have diabetes. So
Do you recommend children getting vaccinated?
So they're still doing the research on that. We haven't gotten there yet.
Okay.
So the vaccine has only been approved, Pfizer, for 12 to 16. And
So why? Why do you think that age was specified?
they're trying to do it into blocks because the physiology of kids to young adults, it changes. So your immune system is changing, your body's changing. So you don't have the same physiology now as you did when you were 5, 10, 15, 20. We're all different. So you have to take that into consideration when you do the vaccines. You have to do the dose and so forth.
Okay. And based on all this, and I remember you saying we were in the fourth wave. Do you think we'll get a shutdown coming soon? I need to know these things.
Yeah, everybody wants to know this thing because they want to prepare this time. They want to make sure, do I
Yeah,
need to stock up on toilet paper?
It was rough.
And,
It was very, very rough.
And water. It's tough. Honestly, we're not going to know, have an idea. At the filming this podcast, in the next 4 to 6 weeks, we'll have a better idea if this winter will get shut down. So.
Well, I hope not, folks, because I don't know if I can handle another year. So now we have a lot of questions we received on vaccines. So we have a lot of questions that we received on vaccines. And one of the things I would like you to kind of give us a better perspective outside of America, right? What does the rest of the world look like vaccinated?
Okay. So based on the data from the ourworlddata.org, shows that only at the time of this podcast, because numbers change. I don't want someone watching this podcast a year from now like, nope, that was wrong. He said this, like, no. So that's why I always preface what I say with the time of this podcast. They showed that 14.5% of the world has been vaccinated as of August 1st, 2021. 14.5% of the world is vaccinated.
Wow.
Yeah. So
For some reason, I thought that number would have been larger.
most people do, because you got to realize the people who are pushing the vaccine are the developed countries. The poor countries don't have the vaccine.
Yeah, and they're not letting us in.
Yeah, they're not. So.
Do you think this virus will ever disappear? Can a virus disappear?
Yeah, it can. There have been viruses, or they can go into like hibernation, because SARS and MERS and H1N1, you don't see them, but they're out there still, and they can come back anytime.
H1N1. That sounds
Swine
familiar.
flu, 2009. Yeah.
You know, you
That was the one that caused the Spanish flu in 1918. That was the one that wreaked havoc in the world, 1918. So, H1N1. It tried to make a comeback in 2009, but thankfully it didn't. So.
Okay, so we do have two types of vaccines. Can you tell us what they are? And from your perspective, which one would you recommend?
So as a scientist, physician, I like to give the data. So the data shows that they all do, all three, the Pfizer, the Moderna, and the Johnson & Johnson, they're the three main ones in this country. And they show that they all do a great job of 90% of protecting you from getting sick. The Johnson & Johnson gives you a 100% chance of not being hospitalized or dying from COVID.
Well, why didn't they tell us that?
Actually, this data is out in the, anybody can read it, so.
Where would we go to find it?
So,
You know, us non-medical people need to know where to go to find these things.
New England Journal of Medicine, Journal of American Medical Association, you know. Do I keep going? So, yeah, it's just, and people need to do more than just watch the news. Like, this is just, you can go to the your county, just real quick. You can go look at the numbers yourself. You can go to look up Pfizer vaccine, Moderna vaccine, Johnson & Johnson, and read the data. Okay, what's the efficacy? What are the side effects? What is the, like, how many people are getting this? Like, and you see the comparison. They have all these charts online with different studies, and you don't have to read all of these journals like I do. I mean, I enjoy spending hours. This is me. I enjoy this a lot. But most people, they say I don't have time. But you can quickly.
Honestly, I wouldn't say we don't have time. We just don't know. Like, I wouldn't know up until.
Yeah, like these charts is public information. You can go look at the 3 different vaccines and compare them. Like, oh, everything I'm telling you to fact check. I did this research, and so I just want to give an example also of because California, where I'm from, it's the vaccines they've done as filming this podcast.
Okay.
They did 45 million doses, and that's 52% of the population in California.
Oh wow.
The people who received 2 doses, 64. Actually, sorry. So 52% of California is vaccinated. 64% have received 1 dose, and 52% have received both doses. And so, you know, they say, oh, we need 70 to 85% to reach herd immunity. So we're off based on that. And in the U.S., there's 161 million people that are fully vaccinated out of the population, a little more than double that. So we're about 50% of the country being vaccinated. So we're far off from herd immunity if you go just based on the vaccinated numbers.
Question.
But then, sorry.
What is herd immunity?
Herd immunity is basically.
Forgive me, folks.
No, So herd immunity is when you have a group of people. I'll give you an example.
Okay.
Texas, back in March, when the governor said, you know what, I'm going to lift the face mask mandate, and there was a bunch of outcry, and all the experts like, you idiot, you're so dumb, that's Neanderthal thinking and so forth. They were basing that assumption on opinion. There wasn't any facts. And I told everyone there was nothing to worry about because Texas, first of all, nobody was wearing a face mask anyway. So back in March, it was a group of people, and everyone was sequestered. They were shut down. Nobody was pretty much traveling. So we had Texas, a group of people who were already sick and everything. They got over it. They're fine. And then they lifted the face mask mandate, and actually the cases kept dropping. So to answer your question, herd immunity is when the majority of people are immune to a disease, and they offer protection to the people who are not or have not been exposed. So Texas was protected, and the cases kept dropping as a result. Then, so people waited March, April, May, June, July. Finally, the cases started going up, and everyone's like, okay, fine, I get my time. I can point the finger at the governor. But if you want to do that, but that's not how herd immunity is. When everyone started traveling, opening up in the summer and traveling in record numbers, Memorial Day and so forth, people were going to Texas. They were leaving Texas. They were going across the world, bringing back different viruses, and that herd immunity went out the window. So you have like different people being sick with different strains. And also look at Israel, for example. Israel had a massive vaccination push. They have less of a resistance than we do. So they had a massive vaccination push. And they had 84% of people above the age of 70 were vaccinated. And then the cases went down in May to 15 per day. They were fully open, everything. And then the cases went up to 3,800 per day at the end of July. 3,800.
What do you think caused
Same
that?
thing. Same thing that happened in Texas. It's like, okay, you're protected, but you
Do
bring
you-
all these other factors in.
Do you think that there was that much travel?
There was a lot of
In
travel.
a-
There was,
in and out of
there was
Israel?
records, like there was a lot of canceled flights. There was not enough flight attendants. If you watch the news, it was pandemonium. People's flights were delayed. It was just people were overbooked. It was hectic, crazy.
Okay, so now I think you said there are 3 different types of vaccines, right?
Mm-hmm.
There is the Pfizer, the Johnson and Johnson, and then the Moderna.
Moderna, yeah.
Moderna. The side effects?
Yes, and that's important to a lot of people. So Pfizer and Moderna vaccines are the ones that are based on mRNA. They're the ones that just make the protein in the cell, and then they don't cause you to get sick. But their side effects were just, chills, headache, pain, a little bit of pain, soreness and redness at the injection site. But it went away in a couple of days. And I wanted to read the actual facts in the literature. They showed that, and you have a rate of myocarditis in kids.
What is myocarditis?
It's inflammation of the heart.
Okay.
Then that was the big thing in the news. Like, oh wow, these young teenagers, they're getting the vaccine, they don't need it, and they're getting like heart inflammation. And the rate of that,
What do you think caused that?
the vaccine, something the vaccine was reacting with the heart.
Okay.
And there was a lot of speculation. They said, well, maybe the dose was too high in young kids. Adults are like, okay, it's fine. But something that a vaccine that has a 100% efficacy in a certain age group is probably too strong. So it could have been like you're overstimulating the immune system to have that. And just wanted to let you know the data that the rate of that myocarditis we're talking about, and it was a big deal, was 0.0012%.
Oh wow.
Yeah, that was the rate of the myocarditis in that age group. And to go along with the side effects, the biggest one in the news, I'm sure everyone knows, was the Johnson & Johnson. They got shut down for a minute, but now they're back, was the blood clots. And then later on, Guillain-Barré syndrome. Guillain-Barré syndrome, I know you're going to ask me.
I need things to be broken down, okay?
No, it's okay, it's okay, it's okay. Like I said, I'm learning how to simplify things. So it's a ascending paralysis where you're paralyzed from the feet all the way up.
Oh, that's not nice.
Yeah, so the data showed that with the Johnson & Johnson, people were getting Guillain-Barré syndrome at a rate of 100 per 12.5 million people. And if you do the math, that's 0.0008% chance of getting Guillain-Barré syndrome, 0.008%. And just as a comparison, your chance of getting struck by lightning are 0.0002%. So you're talking about a rare event. Yes, you can walk outside and get struck by lightning. Yes, you can get myocarditis, but these numbers show you like really to put things in perspective, because people want to know like, well, what's my chance of getting this? What's my chance of dying? So I wanted to give the information to you so you can see that.
So out of knowing all this and having this information, which vaccine would you recommend?
The one you can get, that's just a tough question, because you got to realize it's only 14.5% of people
Currently.
in the world vaccinated.
Right.
So if you have access to the Pfizer, then get it. Don't wait until you have access to the AstraZeneca and in Europe or so. Like, it's just there's other people in other countries, and I tell my patients like, you don't want to take your MMR vaccine, you don't want to take your polio vaccine, but there's kids in other countries who are dying.
Yeah.
And they would love, from the rotavirus, they would love to take the vaccine for you. They're dying from Haemophilus influenza, and they would love your vaccine. They would love that, but we can't give it to them. So with the blood clots, because that was a lot of things in the news, with the Johnson & Johnson, it had panic and there was a pause on the vaccine, caused at a rate of, look at my data, 35 out of 12 million people had blood clots, and at a rate of 0.00029%. Remember, getting struck by lightning is 0.002%. And if you compare it to regular people who had COVID, severe COVID, they were getting blood clots at a rate of 20 to 40%. Mild cases of COVID in the hospital, who were hospitalized, about 5 to 10%. And then in between that, if you had moderate COVID and so forth. But you can see there was a large difference, 0.00,
Yeah.
and then 20 to 40% in the ICU getting a clot, a huge difference. So
And are these patients mostly immune compromised?
they're not immunocompromised. They're just people who, most people getting the vaccine before were the high risk.
Okay.
But a lot of high risk were not getting the vaccine, because they're like worried about the side effect. But my patients who know me very well, they know I'm direct when it comes to things. I'm sure you're getting that from me now, but I tell my patients, I signed over 100 death certificates, last winter, over 100. I had to tell families, crying to me on the phone, no, don't say that, Dr. Jones. I had to watch their loved one die from outside the room, and they can't go in and hug them and say goodbye to them. I had to watch all that. And I tell patients who are high risk, like the guy who was 36, I say, those 100 people would have loved to have a sore in the shoulder. They would have loved to have a blood clot. They would have loved to had a fever for 2 days.
Yeah.
They would have loved to have been sore, for a couple of days, just so they can spend more time with their family. Those 100 people, and that's just me as one doctor. Imagine the other thousands of doctors across the country who had to go through the same thing, like the same thing. And we talked about the patients who were vaccinated and died. It was 0.0 something percent of the patients who were vaccinated who died of who got COVID and died. So it's just, I just want to put that in perspective for everyone. Just, high risk people, like those 100 people, only a fraction, maybe one, would have died anyway. The other 99 would still be with their families, so.
So to put in perspective, what is the chance of dying from vaccines?
The chance of dying from vaccines.
As a whole, not just COVID, but
so the data I found showed that your chance of dying from the vaccines is 0.0018%.
Okay.
Like we're still talking about like really small numbers. I'm pretty sure a lot of people hearing this like, I don't know what that means, 0.1, 0.01, 0.001. And that's why I talk about the being struck by lightning, because 0.0002% chance of being struck by lightning is so rare. You don't walk outside and think, oh, I'm gonna get struck by lightning. It's so rare. You know what happens, but it's so rare you don't think about it.
And then what is the chance of dying from a flu shot, out of curiosity?
So that's a good question. So I'm glad someone asked that question. So just as a comparison, it's a lot rarer than a COVID vaccine, any of the COVID vaccines.
Okay.
And I think maybe one person died from the flu. I couldn't really find any data, but I looked and I looked. I don't want to spend too much time with this, but they said maybe one person died, and they died from anaphylaxis to the vaccine. They didn't die from the flu shot itself, so it's very, very rare.
So one of the questions that did come in, and I'm going to need you to help dissect this for me, okay? They asked what the GBS with the flu shot. First, can you explain to me again what GBS is?
Yes.
And then what does that mean?
So these questions are coming from people hearing the side effects of the vaccine. They're like, oh, well, what's the chance of getting the blood clot with the vaccine? What's the chance of GBS, Guillain-Barré syndrome? That's the ascending paralysis. So what's the chance? And then people want to have like something to compare and contrast. You're like, well, I take the flu shot every year. I trust the flu shot, FDA approved, but should I trust this vaccine? Give me the numbers. So the numbers show that with the flu shot, it's a lot lower. You have 1 in 1 to 2 cases per million, which is half that of the COVID vaccine. It's still 0.00%.
But still.
Yeah, it's still very low. It's very, very, very rare.
Oh, so that's very good to hear.
Yeah.
Okay. And after receiving like the COVID vaccine, can I still test positive?
Like I said before, it depends on when you're tested. So if you get the vaccine, no. But if you're out and about, no face mask, enjoying life, depending on which state you're in, because a lot of states are going back when the face mask mandated, whether you're vaccinated or not.
Yeah, that's
so let's say you're enjoying your time in Texas, you're vaccinated, you're going into stores, and you don't have a face mask, you're still breathing in the air. and you're breathing the air, and you're still breathing in COVID because it's all over. It's widespread. And you go home and you breathe out, and then someone who's not vaccinated or someone who's immunocompromised, they can get sick.
So is there such thing as a perfect vaccine?
No, and the reason there's no, for the perfect vaccine would be, I know people are just trying to be optimistic, but the reason there cannot be a perfect vaccine is because from a genetic standpoint, we're all very different. If you were to put, your genome is this big, and then you have your DNA for your immune system here. Everyone's immune system is not the same. They're not the same. You have some people with a very weak immune system. You have some people with a very strong immune system. And that's why you see everything from somebody having no symptoms of COVID, not even a sniffle, and they have a great immune response. You don't even know they had it. And then you have someone who was in the ICU with a very weak immune system, like the guy in Europe fighting for his life, had 40 different mutations. He had B-cell lymphoma, and then he died. So it's such a broad range. And what these numbers do, and what I try and do with my patients, I try and give you the majority. What's your likelihood?
Yeah.
Like, yes, possibly go outside and get struck by lightning. But should that be your fear of being struck by lightning every day? No, because it happens 0.002%. The same thing that when I ask these questions about the vaccines and mortality rate and kids and natural immunity and so forth, I'm giving you the majority. Yes, people are going to nitpick and say, oh, well, what about this case? What about this kid who was 13 in the news, he got the vaccine and they died? What about this person who had no health issues and they died? So it's like a dichotomy.
Yeah.
And that also is spreading a lot of people into polarizing positions.
Yeah.
Because it's just like, okay, well, the news would say mother's sad because her daughter 15 is fighting with COVID, but then you're sad and you feel compassion for the mother. And then they'll say one guy who was anti-vaxxers, he regrets it. And then another person, who got vaccinated and then they died. But if you look at the numbers, the rate was 0.00 something.
Right.
So you're going to find these rare cases because these cases are all reported. So you're going to find these rare cases, the Guillain-Barré syndrome, the blood clots, the anaphylaxis. Like, you're going to find all these cases, but you have to put everything in perspective.
So if understanding everything that we've heard today and the small ratios, right, of all these side effects and full transparency, would you say a vaccine is better than natural immunity?
It depends on the vaccine.
Okay.
So the vaccine for meningitis, definitely, because if meningitis, from the time you get it, goes to your spinal cord in 48 hours, you're dead. Your immune system doesn't have time to react.
Oh, wow.
That's bacteria. But I know that question came from, I'm so analytical, I think about all these pathways in my head. So the question came from asking, is the vaccine better than natural immunity?
Yeah.
Okay. So very few vaccines are better than natural immunity. There are some. There's DNA viruses, human papillomavirus. It's better than the natural immunity.
So in the case of COVID?
In the case of COVID, thank you for bringing me back, because my mind is...
He's very intelligent, folks.
So thank you. So basically, there is no vaccine for a respiratory virus right now as we're speaking.
Yeah.
At the time of this podcast, I know people say 5 years from now, nope, he was wrong. He said that, and we have a vaccine there is no respiratory virus vaccine for respiratory virus that's better than natural immunity. Better. And a lot of people who you see on TV they don't want to say that, and I get it, because people will take that and say, oh, I don't need a vaccine. I'm good. Yeah, but what if and that goes to that's why I started this podcast with Understanding the Human Mind, because everyone thinks they're good. My patients who are high risk, the guy I saw today, August the 6th, high blood pressure through the roof, a walking time bomb. He felt fine. He thought he was good. He said he felt fine. So I understand from a public standpoint the reason you have to watch what you say. I get
Yeah.
it from a public standpoint. I get it. As a scientist, you ask me a question, I give you the answer. As a doctor,
So if I
too.
had COVID-19, do you recommend I get a vaccine?
What's your question? Are you asking me from a scientific standpoint, or you asking me from a political standpoint to protect other people, to end the pandemic? There's so many
as
factors.
Dr. Jones,
Okay.
if I had COVID-19, should I get the vaccine?
You by yourself with no health issues and no risk factors, and you don't get sick, cold and flu season, your immune system protects you from all the 200 respiratory viruses year after year, you don't need it, okay? Then you expand that to everyone else. Is why a lot of people in healthcare don't say that, is because then you're perceived as being anti-vaxxer, but I'm answering your question. Now, do I think you should worry? Like, for example, I take the flu shot every year. I don't need it. The flu shot's not for me.
It's for your patients.
It's for my patients, because when I'm walking, examining someone with my stethoscope, listening to their lungs and so forth, I'm breathing on them. And if they're immunocompromised, they have cancer or so forth, and they catch the flu from me, even though I survived the flu because I didn't get the vaccine, then I, without knowing, caused them to get sick. And if that patient went later on and died, I wouldn't know. I would not know it was my fault. And this happens across the country. So I get the flu shot for that reason, not because I need it.
Yeah.
So to answer your question, do you need the flu shot? No. I'm sorry, the COVID vaccine, no. But to protect other people, that's a different subject. And so I just told you the reason why I got the flu shot is to protect my patients, because I don't need it. From an immunological standpoint, I don't need it.
So just for make sure I'm fully understanding, COVID, the vaccine should really be taken for people who are high risk and immune compromised?
It depends on your reason for pushing the vaccine. A lot of people are already skeptical because you're incentivizing and all these things,
Yeah.
and saying vaccinate everybody. There's no vaccine that's one size fits all that's for everybody. There's no vaccine. And then there's a lot of skepticism, and you have a right to be. And we live in a country that's fortunate where we have the ability to question things. So that's the good thing about us.
So out of curiosity, pregnancy, right? Do you recommend pregnancy is high risk, right?
So yeah, pregnancy is high risk in itself because your
Okay.
body's going through a lot of changes. And the mortality rate for pregnant women, because I'm sure there's some pregnant women watching this, is 1.6%. And then the mortality rate of the baby, if they catch COVID, is a lot lower than that. And I was trying to find, I looked high and low for the mortality rate of babies who were born to COVID positive mothers. And I couldn't even find it. I mean, based on like the few patients I saw, it was like 0.1 something percent. And that was just a rough estimate because like these numbers were hard to find, so.
Another question that came in, are booster shots necessary?
Booster shots are no. Right now, as we're speaking, they're not necessary. And the pharmaceutical companies are upset with that. There was actually on the news, they're trying to get the CDC and to say.
So what is a booster shot?
So a booster shot is an extra shot on top of what you've already had. So let's say you've got the one dose of the vaccine of Johnson & Johnson or 2 of the Pfizer or Moderna. So a booster shot will be an extra dose of the vaccine to help your immune system, or it will be a new vaccine altogether, a different type. So.
Can you mix vaccines?
The initial guidance has been no, but people are going to do what they want to do. So based on people doing that, they've actually found out, surprisingly, is that overseas, people taking the AstraZeneca vaccine and then the Pfizer actually fared better. They had a better immune response as opposed to taking their appropriate dose of either vaccine, too. So they found that they had a better immune response. So we're getting more data on mixing the vaccines.
So as people are getting vaccinated and there are still vaccinated people getting hospitalized, why is that?
you have a risk of breakthrough infections. So there's nothing in life that's 100%.
Okay.
Nothing is 100%. Your immune system is not 100%. Vaccine is not 100%. But everything comes down to numbers. Okay, so what's my risk? What's my risk I get into a car and have a car accident? What's my risk I get struck by lightning? What's my risk I walk outside and a stone falls on my head? Like, everything's a risk. So breakthrough infections with the vaccine, because it's not 100%, is 0.098%, based on the data that's reported to the different counties.
And what's the chance of getting COVID if vaccinated?
0.098%. Yeah, 0.098%. Yeah.
That's less than 1%.
Yeah. And they
I had to make sure I understood that correctly because it sounded too good to be true.
Yeah. So if you look at this picture right here, is a picture of the breakthrough events across the country in most of the states. It shows that people who are vaccinated have a 0% in some states, some are 0.05%. It's just so low if you look at it that, I just want to put things in perspective with the numbers. So when you see on the news article tomorrow, vaccinated person died, unvaccinated person regrets not getting the vaccine, but it's too late from his hospital bed in ICU. Or you see a teenager develops myocarditis or an adult develops Guillain-Barré syndrome, or you understand what that means. So when you watch the news and you see a person got struck by lightning, you don't think twice about it.
Yeah.
Because the percent is so low. And when yeah.
Okay.
So,
I have a question.
So the numbers, you have to look at the numbers. You have to look at the whole picture, not just one case.
But do you think the news is highlighting those cases because perhaps the population may be a little bit more high risk than one would think?
No, I mean, that's not a medical question, but the news is to get viewership. You want people to watch you. So, you want people to watch you. So you're going to find the exciting stories. You got to find the top exciting stories so people can watch you.
Okay, and can the government require vaccine passports?
That question, from what I've seen so far and what I've read, that's up to the states. Every state has different legislation mandates. The states can dictate, okay, we're going to lift the face mask. Mm-hmm. Okay, we're going to enforce face mask. We're going to enforce some type of passport system in place. Like, every state is in the local legislation. Someone can say, oh, the schools, kids don't need a face mask. Schools in this state need a face mask. So it's
Do you think
legislation's
kids
up.
should be vaccinated or wear a face mask?
So based on the data, like I said, I love that question. What do I think? Because I don't have to tell you what I think. I tell you what the data shows.
Even
because
better?
because that way you can't say Dr. Jones said this. No, Dr. Jones said, what's in all these journals. That's what Dr. Jones said. Just like if I tell you the sun is out. Mm-hmm. Like, I don't control that. You say, is the sun out? Yeah. Is it raining? Yeah, it's raining. The sun's
According
out.
to the data, should kids be vaccinated?
Based on that one study that Johns Hopkins did that showed that the 0.01% mortality in kids, that all of the kids who died unfortunately had
Pre-existing?
pre-existing conditions. Sorry, I'm sleepy. So pre-existing conditions. No, based on that data, no, because zero of the healthy kids died. And like I said, so based on that and the kids who did die who were unfortunate, they should have been vaccinated. Because like I said, I mean, no one wants to watch a kid die. Even the CDC director said the same thing. It's horrible. But we can also protect people. Like I said, everyone's immune system is different.
So back to the face masks, right? Should we be wearing those things inside or outside while exercising?
Well,
according to the data.
It shows that the face mask blocks a lot of air, especially when it gets wet. Mm-hmm. It's more predisposed to being actually contaminated, bacteria growing on moisture. So while you're working out in the gym, no. I mean, you don't want to just completely discard.
And what is the proper way to wear a face mask?
I wish I had one on me. But I covered that in one of my other podcasts. But it's just just the way,
And do you recommend they change it out after?
you're supposed to
Or,
change
or
it.
do you like wear it all the time, the same one?
No,
throw
no,
it in
no,
your
no,
bag
no,
and
no,
put it
no,
back
no, no,
on?
no. That's the problem because it's contaminated.
Yeah.
And you're touching a contaminated mask every day.
Yeah.
So it's supposed to be changed every day, but people don't have the finances or just don't want to do it.
Or don't have the knowledge.
You had to do it every day. So.
Okay. So do I need a face mask for the Delta variant?
So yes, because it's a respiratory virus. It's still a virus. So it's easy in life to get bogged down by the details. Oh, the Alpha variant, the Delta variant. It's easy and to be blinded, but if you step back, these are still a respiratory virus. It's still transmitted by droplets and very rarely by contact on surfaces. So you still need to have a mask to help it. A mask is not 100%, but it
Yeah.
does offer some sort of protection.
Okay. And how did they come up with allowing masks for children 2 years old and up?
I'm surprised more people don't ask this question because people are like, well, why was it age 2 and not 3? Well,
Right.
why was it not 1 year old? Why wasn't it 4? Like, how did they come up with this? So masks are recognized by the CDC as a choking hazard. So they said, and I want to quote this because anyone who is wearing a mask should be able to remove the mask, and that's not a guarantee when you're under 2 years of age. And they also said that when deciding whether children or people with certain disabilities can wear a mask, the CDC recommends considering whether they can wear it properly, avoid frequently touching their face, limit drooling or sucking on the mask, and remove it without help. Young children are unable to vocalize if they can't breathe well. If they have trouble breathing while wearing the mask, they can't tell you that they're having trouble breathing. So that's why they said, okay, well, just like to back to your question, it's simple. It was an arbitrary age based on choking, and
Yeah.
that was the reason based on that. And they did a study of kids, a randomized controlled trial with a p-value less than 0.01, which means it's actual authentic study, to show that kids have a high risk of retaining carbon dioxide with the mask and don't wear it properly. So a lot of times when kids were complaining, oh, mommy, I feel dizzy, or I'm lightheaded, I'm nauseous, or they kept pulling their mask off, there was a reason for it. I mean, a lot of parents said, oh, my kid's just being fussy. Well, they can't breathe. And they measured the CO2 levels in kids in Germany in this lab. I'll post you look at this paper right here, just for your edification. And it showed that after 3 minutes of mask wearing, that the CO2 levels went three times higher, the upper limit of normal. So, and when your carbon dioxide levels go too high, you have the risk of nausea, vomiting, dizzy, confusion, even seizures. So that was actually one of concern. And, adults, they did studies where you put on 6 masks and your oxygen level stays exactly the same. So adults, you see people with 2 masks, 3 masks, 4. That's not necessary, but their oxygen levels are normal. But kids, which I'm not sure why, it's not my area of expertise, kids are having higher levels of carbon dioxide when they wear the mask. So that's just something that is of concern.
So one of the things that is becoming very new is this digital health pass.
Mm-hmm.
So I kind of want to definitely touch upon that. We've received a lot of questions about that as well. Where are they now? What is a digital health pass? So
a digital health pass is a simple term for your COVID passport. It's your, I'm vaccinated, here's my card, I don't need to wear a face mask. I'm vaccinated, I don't need social distance. I mean, it's just, that's what that is.
What are the benefits of that?
Well, the benefits of that is, which is not going to work now because of what I discussed earlier, but the benefits, the premise was, okay, well, people can be more comfortable. Mm-hmm. We can open up businesses, schools, we can go back to social gatherings, have a normal life again. If you have your card. So you have 20 people all vaccinated, the thought was, okay, well, we're fine. We're safe, we don't have to follow the rules, we're protected. And that's the premise for any vaccine. But as I've showed the cases with Delta and transmitting and so forth, that is not a likely possibility at this point.
What challenges are there with that?
The challenge with that is like, okay, well, which vaccine did it get? The efficacy of the vaccine. It's how long does immunity last in the vaccine? Like your card, is it good for 2 months, 6 months, a year? We don't know. We have anecdotal study to show that the vaccine protects you at least 6 months, some say 8 months. We're still gathering information. So that's one of the things. And also, there's different variants, different strains. So you have your vaccine card, then 2 months later, you get a variant, getting sick, and you give it to everyone else who doesn't have a face mask. So it's just a lot of these different components. And also, is it ethically,
And how are these regulated again?
This would be like the legislation, local legislation.
Local,
Yeah.
so by state. Everything seems to be by state.
Yeah.
Okay. And can private sectors mandate the digital health pass?
They can. Private sectors can do that and say, hey, we want our employees or so forth to get the vaccine, or they can say have a digital health pass or a COVID passport. But the like a lot of states are shooting that down. Some states are saying like, okay, well, you want to do this, but telling the private sector they can't do it. So yeah, there's a lot of things going on.
So what do you recommend to maintain a strong immune system?
Okay, so a strong immune system is a whole list. What I'm going to say is nothing that the doctor didn't tell you back in 1960, the doctor didn't tell you back in 1970,
Yeah.
1980. So it's just, there's a couple of new things we found, but for the most part, make sure you have a healthy weight. Your weight, we're finding that as you gain more adipose tissue or fat cells, you're putting your immune system in a hyperinflammatory response. So, and we know that COVID, when it attacks your body, your immune system becomes inflammatory. So you have that extra inflammation on top of being inflamed, which is making, overweight people die at higher numbers than regular weight people. And then that along with, diet, exercise. So
Yeah.
then second, exercise. When you exercise, you increase your T cells and your immune system gets stronger, and it can protect you better. They found that 30 minutes after exercising, your T cells in your bloodstream are increased.
Oh yeah, that's that energy boost.
Yeah, so
Yeah.
exactly. Yeah.
Sleep.
And sleep, a good night's sleep improves your immune system, and that's just from the vaccine standpoint. They found that the vaccine works better if you have a good night's sleep too.
What's considered a good night's sleep? I can survive off of 4 hours.
Well, people survive. That's
Yeah,
another
so
topic.
wh-
Yeah.
so what's
a good night's sleep is when you function throughout the day. You don't need a nap. You don't feel drowsy. You don't need coffee. You don't feel groggy. You can think. You have So that's a good night's sleep. Whether that's 6 hours and someone 70 years old, 10 hours and someone 4 years old, 9 hours and someone 12 years old, or 7 hours and someone 20. It varies.
depends.
Yeah. So a good night's sleep. And the other one is reducing stress. Stress causes inflammatory cytokines in your body, which is part of the immune system, and free radicals that destroy tissues in your body. So when they say that stress kills, that's not an exaggeration, because you're doing damage to your tissues with stress. And then also, what's next? Vitamin D from the sun can help you. The more natural, you can take supplements. But like people who take supplements in this country, you got to be careful, because you can have too much of a good thing. Vitamin D is also responsible for calcium absorption. So if you take too much vitamin D, calcium can go high and cause bone pain and cause nausea, vomiting, all that. So be careful with the vitamin D.
Okay.
Vitamin D is a steroid, and vitamin D actually has been shown in a lot of clinical studies to help your immune system with respiratory viruses. I'm not going to go into the details. There's a lot of videos on YouTube about that and papers showing the mechanism for how vitamin D is actually a steroid, it's a hormone. It actually can go into the cells, into the nucleus, and modify a lot of things in a good way. So definitely vitamin D. Zinc also has been shown to block the virus and binding to the respiratory cells. But again, too much zinc can cause like stomach upset, nausea, and everything. it also blocks copper from being absorbed in your GI tract, in your intestines. And copper is important for a lot of functions in your body, like your bone health, your muscle strength, your memory, things like that, collagen synthesis. And you can get copper from like oysters, dark chocolate. I know people want to hear that. So it's a balance with everything.
Yeah.
Get a good night's sleep, not too much, not too little. Exercise, not too much, not too little. Vitamin D, not too much, not too little. Zinc, not too much, not too little. Probiotics are good also. They're found in something called the gut microbiome, that you have a lot of these bacteria produce peptides and hormones and proteins that help to your immune system. And a bunch of other functions also. So probiotics are good also. Daily multivitamin with minerals if you're not eating a well-balanced diet. And the last thing was the cryotherapy. Cryotherapy has been shown, which is what the athletes do to help.
What is cryotherapy?
Cryotherapy is when you sit into a bucket of ice after training, or you go into a liquid nitrogen air for like 3 minutes. I do cryotherapy sometimes. It actually has benefits like reducing inflammation in your joints. It also helps, for some reason, they're finding that it's helping to increase your immune system, making it better. It increases anti-inflammatory cytokines by your immune system, increases your white count and natural killer cells. So your innate immune system, which is part of the preliminary immune system, it helps it to fight infection faster.
Oh, wow.
So yeah, so these are some benefits that people can do. But at the end of the day, if you summarize all of those benefits, it's not just for COVID. It's for everything in life. For your health, for your high blood pressure, for your diabetes. It's just simple things you can do.
This has been great information. I'm very appreciative for you sharing it.
Thank you. You're welcome.
You're welcome.
So in conclusion, thank you for coming and watching this whole podcast. I know it was a lot of information and you're still trying to wrap your head around everything. So just a real quick recap so that whenever you're watching the news and you hear something that scares you, like this young kid died of COVID, this person was vaccinated and did the whole social distancing face mask and washed their hands and they died, and the breakthrough infections and cases on the rise and this mass hysteria, it seems like, and what's the truth, and you're nervous. Let's just kind of take a step back and look at the numbers and put things in perspective so that when you do see these cases, you're not scared. So, for example, let's take a look at this picture right here. This actually shows you an idea of the landscape across the country, COVID-19 deaths by age group as of July 21st of this year. You take a look, you'll see 0 to 17, not that many, 18 to 29. As you go higher and higher in the age group, you see that the numbers shoot up. And if you do the math for infection fatality rate, you see that in the age group of 0 to 17, the fatality rate is 0.001%. And as I mentioned before, there was a Johns Hopkins study that no healthy kids actually died from COVID. And also, if you look at the math, also from 50 and above, that age group comprises over 95% of the fatalities in the United States. So if you were to vaccinate that age group by itself, that would make a huge difference in deaths in the United States based on COVID. But as a reassuring also, if you do the math by the number of cases, 633,000 divided by 36.5 million cases, the infection fatality rate is only 1.7%. So that's just something. I just wanted to show this for you so you can see the mortality rate across the different age groups. Everyone wants to blame this person, this group, or so forth for COVID cases going up, and so. But it's not. Like I said, it's everybody. Every time you're just breathing, talking, just normal speaking, you breathe out 100,000 respiratory droplets into the air every minute. If you're infected and you don't have symptoms, one single sneeze and one single cough produces 200 million droplets into the air, and depending on the airflow, it can travel more than 6 feet. And everyone wearing the face mask halfway on, off, these small plastic barriers that don't do anything. They're just touching their hands and everything. It's just, everyone is spreading COVID. It's everywhere. So everyone is actually contributing to the cases going up. It's not just one group or one person. For example, COVID, there's 9 different variants. The main one of concern is Delta because it's replicating 1,000 times faster. Viral load is 1,000 times higher than normal SARS-CoV2 from the beginning of the pandemic, 2019, and is mutating at a rate of 25 times per year, which is only half as fast as the flu. And just real quick numbers in the vaccines, Pfizer Moderna has mild side effects. So myocarditis in the teenagers has a rate of 0.0012%. Johnson & Johnson has a side effect with Guillain-Barré syndrome at a rate of 0.0008%. The chance of getting COVID if vaccinated, 0.098%. If your chance of being hospitalized if you've been vaccinated, 0.039%. Your chance of dying if you've been vaccinated from COVID, 0.0027%, and most of that was over the age of 65. So the age group of 65 and above, you do the infection fatality rate is 1.3%. So from 1.3% to 0.0027% is a huge difference. And we're just waiting for the vaccines to be FDA approved. The FDA has to go through hundreds of thousands of paperwork files. Back in the day before computers, there was a big UPS truck with all of these files. Like, it's not that simple. They go through every single person's side effect and so forth. Like, for them to put their stamp of approval, there's a lot that goes into it. A lot that goes into it. So they said, for the director of the FDA, that maybe by late fall, FDA approval. So just in closing, there's over 200, so there's 200 respiratory viruses out there. So you got your COVID vaccine, that's great, I commend you for that. But don't forget, there's 200 other respiratory viruses out there that kill people every year. So it does not take away from the fact, and they keep mutating. And SARS is still out there, MERS is still out there, the H1N1 is still out there. And people die, and there's a risk with everything in life. Your chance, for example, of dying from getting in a car accident is 0.0, I wrote it down, 14%. And we talk about kids dying, 10,000 kids die every day in the world from hunger. And that just something that makes me sick to my stomach, but these are real numbers. Like, there's a risk with everything in life. Getting into your car, driving, getting in the airplane, everything has a risk. But with these low numbers, with the vaccines, the side effects, hospitalizations and so forth, hopefully they reassure you that these things are actually safe. And do your own research, please. Like, I got these numbers from online, do hundreds of hours of research myself. You can do your own research, watch the news and fact check, find out, put things in perspective and so forth. On the bright side, with the SARS coronavirus 2, the mortality rate is so low that we can get away with halfway doing everything. Every state doing what they want, every system, everyone doing every business doing what they want, and we get away with that. But if this was the Marburg virus, we'd be in trouble doing what we want, okay? So in conclusion, hopefully you learned a lot. I will keep doing my reading and so forth, and you can catch me on Instagram. I post a lot of journal articles and so forth from everything that I read, and all these journals that I read right here, just want to show you. I post there so you can get a lot of good information. And if you don't have Instagram, I do have my social media person put the same post on Facebook, so you can see it on Facebook also. So, all right, be safe, and until next time.